So now in this question, we have liquid water and we have carbon dioxide gas, and those are going to form this aqueous glucose and this oxygen gas. And what's going to happen here is we want to know how many moles of oxygen will be produced from 0.06 moles of carbon dioxide. And so what I'm going to do is I'm going to write down the chemical reaction for this. So I'm going to write down that we have this H2O, and that's going to be a liquid. So I'm going to put a parentheses here and put an L for liquid, and that's going to combine with this the carbon dioxide. So let's put down that we got CO2, and that's going to be a gas, and those two things are going to produce this glucose right here. So I'm going to write down that we got C6H12O6, and that's going to be aqueous. I'm going to write down AQ here in parentheses, and it's also going to produce this oxygen gas right here. So I'm going to write down that we got this O2, and then we'll put a G here in parentheses for gas. And the first thing you want to do is you want to balance the reaction. So let's go ahead and do that. And to balance this reaction, notice that I got the oxygen here, here, and here. So I got oxygen in every chemical that's part of this reaction. And so oxygen is not going to be a good one to start off with. Let's start off with something like hydrogen. I have hydrogen here and I have hydrogen here. So that's going to be one that I'm going to try to balance first. And so over here I have 2 hydrogens, and then over here I have 12 hydrogens. And so I got to get more hydrogens to this side. So what I'm going to do is I'm going to put a 6 right here, so I can have 6 times 2 like that, because each water molecule right here has 2 hydrogens. And what I can do is say I need 6 water molecules, and each of them has 2 H's, so that will be 12 H's on this side. So I got 12 H's over here, and then 12 H's over here. So the H's will be now balanced. And what I'll do now is I'm going to go after the carbons, because the carbon is going to be here, and the carbon's here. It's only in 2 spots, one on each side of this reaction. So if we go ahead and look at this carbon right here in the CO2, I have 1 CO2 molecule, and 1 times 1 would be 1. So I can say I have 1 carbon right here, and then I have 1 molecule of this glucose right here, so 1 times 6. So I'm going to have 6 carbons over here, and so I got to get more carbons to this side now. And so what I can do is say I can put a 6 right here, so that I can have 6 times 1. So now I have not 1, I have 6 carbons, so 6 carbons and 6 carbons. The carbons are now balanced. And now that I did those, I can go look at the oxygens now. And so what I can do is say, okay, I got 6 right here times 1, so I got 6 oxygens right here. I have 6 times 2 there, so I'll have 12 oxygens there. So altogether on this side, I'm going to have 18 oxygen. Now I like to underline this O right here so that it looks like 18 oxygens and not 180. So I have 18 oxygens there. Let's count the ones over here. I have 1 of these molecules of this glucose right here still, so I'll do 1 times 6. So I'm going to have 6 of these oxygens in here like that, and then I have 1 right here, so 1 times 2, so I'm going to have 2 oxygens like that. So I need to get, I have 6, 7, 8, so I have 8 oxygens on this side, so I got to get more oxygens on this side. And so what I can do here is I can put down a 6 here, so I won't have 2 anymore, I'll have 12, so I can do 6 plus 12 oxygens there, so I'm going to have 18 oxygens on this side, 18 on this side. So now the oxygens are now balanced. And so now that we balance this reaction, what you want to do next is you want to put down what you're given as part of this problem under each reactant. So for example, see how I got this 0.06 moles of this carbon dioxide? I'm going to go ahead and put that under this one right here. So I'm going to say that I have 0.06 moles of this CO2, and then what I like to do is I like to put what I'm going to find as a question mark under that chemical. So in this question, it says I'm looking for how many moles of this oxygen right here. So I'm going to find oxygen. I'm going to put a question mark, and then I'm actually going to write moles right here. That way, when I finish the problem, I know that I need to be in units of moles and not grams. And so what I need to do now is I'm going to put down what I'm given, that I have 0.06, and that'll be moles of CO2, like this. So this is what I'm given, and what this problem tells me is that for every 6 of these that are going to be used up, I'm I'm going to produce 6 of these. So this right here, part of the problem, this is going to be what I'm given. And then this part of the problem over here, that's going to come from the reaction, the balanced chemical reaction. And so what I can do is just, I'll put down that I got CO2 here, and then I'm going to put down oxygen right here. And from the reaction, it tells me that for every 6 of these CO2s that I end up using up, I'm going to produce 6 of these oxygens. So the CO2 here can cancel with CO2 here. And then what I can do is I'll take this right here times 6 divided by 6. Well, 6 over 6, that's going to be 1, so that basically goes away. So then what I'll have here is going to be 0.06, and now I'm going to be moles of, not CO2 anymore, I'm going to have moles of O2 like this. And so this right here will be the answer to the question.